Hi, this is Lester Martin with Hortonworks University, and I'm going to do another demonstration on our Hadoop Essentials one-day course offering. And as I mentioned on all the other ones, these demo instructions and notes are here on GitHub under Hortonworks University on a repository called Essentials. So definitely don't hesitate to try to reproduce these by yourself a little later. As we go down, we're focusing now on the risk analysis with Spark, and it actually has a title just like the other one, Risk Analysis with Pig, that I recently did. And the reality is we're going to do the same driver risk analysis with Spark that we did with Pig, just to do some compare and contrast, and to show you another tool in a larger ecosystem. That said, there is a prerequisite to do that risk analysis with Pig. There is one table that we've created with a CTAS in that, so you'll want to at least go reproduce that one table if you don't want to try to reproduce the entire demonstration. And like the other demonstrations, these are based on some publicly available tutorials on the website. Said links are right there for you to try to produce those on your own. So what we'll do is just jump on in. And we're going to be focusing on Spark, like I said, and we'll be using the Zeppelin notebook to do most of our work in there. So when you get going in a notebook, what you usually do is you create you some kind of like a new note, and we'll just call ours compute, risk factor with Spark, I guess. Yep, that sounds like a good note name. And what you'll kind of see in these notebooks is just a kind of these little snippets, little pockets of windows. I believe they call them paragraphs the most time. And this is, in many ways, just like the traditional Spark shell, but just kind of wrapped with a bit of UI experience and those type things, and letting you run things a little easier and replay things without having to constantly replay them. So just get the conversation started. Just to kind of show you, we are focusing on using Scala here, and this is kind of that environment, what it looks like. And let me see here, 1 second. And that finished, and really what we're trying to do this early on, just to get started, is really just trying to get a hold of or create a hive context. So this is some imports to get that going, but we'll use the Spark context to create that, and that will be our interface point to things in Hive, to find things, query things, in fact, to store things back into Hive. And now that we do have that Hive context, we can do straightforward things that we could do directly in Hive. For example, here we use the Hive context as SQL method, and then we'll just run some operations. So we'll run a show tables and then just via some Scala codes to kind of loop that through. So these are the some of the tables you probably recognize: that driver mileage, the trucks, the geolocation tables that we did earlier. And what we're going to do here is go ahead and we're going to load up into a Spark data frame, a Spark SQL data frame, the data that is in the geolocation table that we just mentioned right there. So I'll run that, and we're going to call that variable just geolocation all, and then I'm going to preface postfix everything with the underbar data frame, just to kind of let us know that that's what we're talking about. Those are data frames there. And now that I have that, it's pretty simple just to do a show on that geolocation all data frame dot show, and then show we'll just ask for the about 10 records. Looks good. We'll kick that off. And as you kind of see what I'm doing, I'm just building these little individual, again they call them paragraphs or code snippets, might be the thing you might refer them to. And these will let you go back and rerun things from earlier, if that makes sense. Or once things have been created and exercised, you can continue to leverage them in the rest of the notebook here that we're using. So that shouldn't be too unique. That's the geolocation table that we did earlier. But what we can also do, and we have a concept in Spark SQL that we're playing with here. It's called registering attempt table. So sometimes, now this is kind of beating around the bush by the fact that geolocation as a table name already exists. But if I manipulate this, and we'll do that shortly with some other examples, I can take any data frame and register it up as a temp table. And by doing that, that will let me use that name, use that data frame in a follow-on operation. So that didn't do anything, it just kind of quickly showed there, but let me show you what that looks like when you do use something. So here's a query that's actually going to generate, it's going to glean out, here, I'm going to kick it off while I'm talking. It's going to eliminate all the drivers that don't have any non-normal, they don't have any risky behavior, and we'll clump them by the driver ID, and then we'll basically get a count of those count of the non-risky behaviors or the non-normal behaviors, aka the risky behaviors. So that's what we created, and I went ahead and that data frame is something we built. It's custom to us, and we might want to use that again in another query, which we'll probably do in just a moment here. So I'm going to say risky driver event counts data frame dot, and then we'll just see what that table itself looks like, or that data frame that we can think of in our mind as a table. And what's kind of, I don't know if unique or not, but nice definitely with Spark SQL, is we get we can use our familiar SQL language that we that most of us all know and know really well, and I'm just going to paste down here the alternative. I could actually run, and I'll kick it off and run, and I'll walk you through the code. I can use the data frame API to do the same exact kind of thing. So I had that geolocation all table. So everything in geo, we can filter it, we can group by it, we can do counts, and then in all reality, I switched the name of the column so it wouldn't be called count to occurrence, and then did show to, and then what you see on top and the bottom is actually the same end result, based on going down either the SQL path or the data frame API path. So you can actually mix and match a little bit of that at times if you care to do that. But usually folks find themselves a little bit more leaning toward one or the other. So at that point, what we're going to do is we're going to join that table we just created, that new data frame that we just created, with the driver mileage table itself to give us a little bit richer information. And probably the best thing to do is just output on the screen to show you what we have there. So I'm going to call that joined data frame show. I'll show again just 10 records. Take that off. And as you might see on screen there, well, I guess we'll give it a second to finish. I might even cheat a little bit and go ahead. I'm going to, while we decipher those results, let me kick another something else off, because what I also did is compared and contrast that SQL statement version with a API version. So really, we just want to augment some information with that join. And there's our SQL version at the top, and there's our data frame API version at the bottom. And here's a good example where sometimes I do have to, if I'm going to use an existing Hive table like driver mileage in a query, it's no problem, and it's just a string-based query. But if I'm going to use that table, that Hive table in the API version, I definitely have to create a data frame object that then I can leverage within that. So this is just an example of a join that we did there. So we did it both ways. But what did we really come here to do? We really ultimately wanted to calculate that risk value that's really based on the just like our pig example, based on your total miles divided by how many risky occurrences you have to create some type of risk factor. So we're going to get that information, and I went ahead this time bundled, not just running it, building it, but go ahead and I registered it so I could leverage it again in SQL, and I went ahead and dumped 20 records on the screen there. So what we'd like to do now is this is great. We have this information, kind of floating around here in Spark, but we really want to persist it back in the Hive so other systems can take advantage of it. So what we'll do is, just like before, use that Hive context object, SQL method, and we'll run some Hive QL. In our case here, we're just going to create a new table. And if you remember the pig demonstration, you'll notice this table looks a lot like the other one. It's almost exactly the same. We just called it risk factor Spark, added the additional name there to tail end, but it's drivers, the driver ID, you know, the number of risky events, total miles they had, and then the risk factor itself. Now we calculated that risk factor up here, so we'll have that in a second. So this is just a base table, nothing too exciting from that. And we can actually go take a quick look and make sure that table did get created. So I'll run over to Embari, look at the Hive view as we come in here. And I think that table is called, there it is, risk factor Spark. And just to show, it should be empty, so we'll just run a quick query, and there's no results as expected. And that's okay. We had created an empty table. So what we want to do is ultimately want to get the field or the data frame that we call risk factor calc. It's up here. Let me kick something off here and I'll explain it. It's right here. The risk factor event counts. Is that right? In fact, what we're trying to kick off is this risk factor calculator frame. That's this information we saw over and over. We're going to put that into the table. So what we have to do is we have to actually, we made this table as a ORC back table. So we need to take that data set that Spark is chewing on and working on and actually save that back onto disk in HDFS as an ORC file. And we did that here. So we ran a program that said, hey, write that information out, and this is just a URL of where this information is. So we'll take a moment and go look and make sure that that made it. So I'm back in Embari, I'm looking at the Hive HDFS view, and then we just happen to be in user, oops, went into temp, get back. We're in user, Zeppelin, and this is what we created was this. So it's a directory, risk factor orc, and in fact these are a bunch of orc files that back up that information. So it did make it. What we're also going to do is take a moment. I'm going to switch back to where we are. So we have some information loaded on disk, and then at this point the good news is we can just do another Hive operation. We can ask Hive to, like we could do anywhere else, simply run a load data, find this data on HDFS and load it into the table risk factor Spark. Now if that goes true, like I said, as soon as it finishes that operation, we'll switch over to the the Hive file view, and it says it is complete here, and we'll make sure that that table did get loaded. So we'll go back to the Hive view, and we will simply pop that table one more time since it should be loaded now. And let's see if some data actually shows up down here in the results section. And it did. Excellent. There it is right there. So risk factor Spark is loaded. So let me see. Take us back to the sandbox here. I'm sorry, the Zeppelin UI. So now we've loaded that table, and really at this point what we've done is reproduce what we did in Pig. So we created these truck driver risk factors. But what we'll do now in Pig, we pretty much said, hey, there's no native tools to help you visualize that information, but we definitely have those tools available to us here in Spark. So what we'll do is just keep on going. In another paragraph, we'll just turn it around and say, you know what, maybe we'll just create a separate, we'll keep it in the same notebook, that's fine. So we're going to run a query that just says, go get everything from risk factor Spark and load it up for us here in the notebook. So that information did come back, and for the most part it looks like what you'd expect, just your tabular information. But what we have inside of Zeppelin is an opportunity to start playing with massaging, trying to interpret some of the information that's showing up and what we received here. And the good news is, we have a variety of tools here, but what's going on is we can actually start manipulating this. So just like any other kind of visualization tool. So in our case, I think what we will probably do is we definitely want to kind of put our our keys here that the drivers along here, but instead of looking at the sum of events, because that may or may not be misleading, why don't we take the risk factor itself and make those the values? So you see that information kind of flip. So now we can see these kind of highs and lows that start to exist, and down to individual folks. Driver A 46, it's got this risk factor score 640,000, etc. And we get to see some, again, some differences in data across these information. So the good news is, we can do whatever we want here. Just to kind of drill it home one more time, why don't we just do a slightly richer query instead of just looking at the table alone? We'll join it up with we'll join the risk factor information that we calculated with the geolocation information, just a couple fields, the city and state. So you see our normal, tabular information, and we can, just like before, dabble around and see if there's something that helps you to find some correct values, insights, that kind of stuff. So you have to experiment with these tools, of course, to see if there's a right answer or not for you. And one thing we could do is manipulate over to the scatter graph here. That was actually a good looking one right there. Does it provide you information or not? That's for you to determine. Use these tools, but definitely some pretty interesting perspectives. And then maybe the one that I like a little bit is if we tag the x-axis, so a driver ID, the y-axis with the risk factor. That looks good. And then maybe we drag city, we'll group them by cities. Oops, excuse me, not state, by city. And then maybe we lay the size down to actually, the thing that we do in different sizes is in fact the information about which ones of these has a bigger footprint, those type of things. So these pictures get a little different size. So you're gonna have to obviously manipulate and play with your screen size sometimes to make this look as best as it should or could be. But this really wraps up. Really, what we want to do is focus on making sure that we can reproduce the same risk analysis with a different tool. Instead of Pig, we use Spark, and then show the inherent notebooking style concepts that exist in the Zeppelin package. That's a Tech Preview and HTTP 2.4. So hopefully you enjoyed the demonstration and look forward to the next one.